Okay, we're going to talk about how to graph a radical function. So this is a square root of x function, and I'm going to start by plotting some basic points. I'm taking the square root, basically asks what number times itself is equal to, in this case, x. So if x is 0, the square root of 0 is 0. If I use a 4, the square root of 4, the number times itself that gives me 4 is 2. I can plug a 9 in for x, not because nice perfect square, because the number times itself that gives me 9 is 3. So I've been able to take the square root of all of those. You can never take the square root of a negative number because no real number times itself will be negative. If it's a negative times a negative is positive, and a positive times a positive is positive. So that's important when I graph this. This is my starting point, 0, 0, and let's say 4, 2 would be about here, and 9, 3 would be about here, and this is what my half parabola looks like. And again, I say it's a half because the other half would look like this if I had it, but I do not. I only have half of it. Okay, so because I can never take the square root of a negative number, we look at the domain of this function, and it starts at this point, which we're still going to call my vertex, which in this case is located at 0, 0. So the smallest x value on my domain is 0 and all positive numbers. Okay, and this particular graph, as we go from left to right, we see, that this function is increasing in its base function on its full domain. So it's increasing from 0 through positive infinity as well. Now, what we're going to talk about, since it is basically a half parabola on its side, this still has a vertex form. So let's talk about the vertex form of this object. So a times the square root of x minus h plus k. So this has a vertex at the point hk, and a couple of important information. If a is a positive number, we're looking at a graph that looks like this. However, if a is a negative number, we're looking at a graph that looks like this. We're just flipping it over. Instead of going up, it's going to go down, all depending on a. So here's an example. Oops, sorry about that. Negative square root of x minus 2 plus 3. So this function has a vertex at 2, 3. The a equals -1, and that is a negative number, which means my graph will open like that, starting at that point, 2, 3. So I'm going to go ahead and make that graph now. So I'll start with the point 2, 3, just making a rough graph. So we'll put that about here. Actually, let me flip that. About here. And it's opening like this. Now, it may not be the best graph, a little bit more looking like a parabola, like that. So there is my graph, and we can basically describe all the properties from that. This particular graph looks like it will cross the x-axis at some point. So it does look like at some point I will have a y value equal to 0. So if I wanted to solve and find that point somewhere over here, where y goes to 0, I'll go ahead and find that by plugging in the y value is 0 and solving this. I'm going to add this component to both sides so I make it positive. I'm going to remove my square root by squaring both sides. And then I will add 2 to both sides. So when x is 11, y will be 0. That's the point we were looking at over here, somewhere over here at 11, 0. Why is that an important point? Well, because if I was to extend this over here through that point, well, actually, let me make that black. And here's my graph. This part of my graph is positive. This part of my graph is negative. So this particular radical function also has a positive and negative component. So it's positive from when x is 2 to x is 11, but definitely not at 11 because that's where x is 0, and 0 is not a positive number. And it's negative once I pass 11. My domain, I can give you that. So my domain is all the possible x values. This starts at an x value of 2 and goes to the right forever. I can also give you my range. Since I know that this is going down, my lowest value is going to be going to negative infinity, and this is the top y value at 3. So once I came up with the vertex and an appropriate graph, found for this particular graph the 0, I was able to answer every conceivable question about the graph.